The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning. This is Salim Khan with the Texas Energy Engineering Services, known as TEESI Engineering. So today's topic is that I will be going over some energy efficiency standards which mostly apply to DX system. Before I get started, I think I want to give a couple of maybe 30 seconds more. There are a couple of people still trying to sign up. So we'll just give them a few more seconds and then I'll get officially started over here. Thank you. So I think people are still signing up, but we can get started. Again, I'll be going over some energy efficiency standards for DX systems and their impact on and how to prepare, and just give you all a broad overview of what's coming down the pipeline and what has been done in preparation for that. So I think this will be a good overview of the entire process, and then we can go into a little bit more detail on a couple of items over here. I think this is second last in the series of the webinar for this month. We have one more this afternoon that will be going over the solar PV system. So we will have that presentation. I believe it's at 1 o'clock. So just to give you all heads up, some info for you all in case you all have any questions. I'll be leaving close to maybe 5 minutes or 10 minutes at the end if there are any questions or discussion points. If you all have any questions or comments, you can put them in the chat box over there, and then we'll address them. Also, want to make sure that you all are aware that you can call us even after the presentation. And if you have any questions, we'll be glad to go over and answer those the best we can. The topic is it's not, I won't call it new, but people are realizing that just recently. So that's why I wanted to make sure that we go over some of these aspects so that you are better prepared in handling and answering some questions that might come up over here. I want to give you a quick overview of what the presentation is going to look like. My first 1 or 2 slides are just going to be the program that supports these kind of presentations to give you all a little bit info on the SECO. Then I'll dig into the 2023 energy efficiency changes. We will go over the 2021 climate zone map changes. I think it will be good to go over the International Energy Code climate zone maps. We will like to go over some basic definitions for rating terminologies in the HVAC systems. And then we will have a little discussion on minimum efficiency standards in 2021 Energy Code. And then in the end, I've got 1 or 2 slides because there is an impact coming down the line, or it's already in the process, which is emissions and refrigerant transitions impacts over there. So there are some changes in the refrigerant coming down the pipeline, and just like you to be aware of it. And in the end, we will have maybe 4 or 5 minutes or maybe 10 minutes to answer any questions. So that's the general overview of the presentation. And my goal over here is to give you all some fundamental kind of information as to what is happening in the industry and how people are addressing that. And then just want you all to be aware of some of these common terminologies and things that you will be seeing coming down the pipeline. So well, just very briefly, this presentation is sponsored by the State Energy Conservation Office. We are one of the engineers that do perform for State Energy Conservation Office. And the local government energy program is the one that deals with preliminary energy assessment, energy technical assistance to public entities. And the other program that is very popular at SECO is the Lone Star program, which which is a funding source for water and wastewater energy efficiency projects. So, anyways, I just want you all to be kind of aware of that. Most of you are very familiar with this and have participated in this program, but I still wanted to just go over a few slides over here over the program. So this is a program, the schools and local government program is available at no cost to schools, local governments, and primarily any public entity can apply for that and they'll get the desired service. One thing I want to make sure is that this is not a design service or performing detailed energy assessments, but these are initial assessments that are available that people could utilize. So something to keep in mind, but it's been very popular and it provides the basic information to a lot of entities so they can plan their activities related to the energy efficiency projects. Participation is very simple. It's a one-page document that you can download from the SECO website. Primarily, you just have to answer your contact information, address, and so forth, and answer 2 or 3 questions about your familiarity with the SECO programs. And then you sign and you turn it in, and then from there, the process starts providing free technical assistance, basically. If you all have any questions, LaShawn Menace is the program manager, and I'm one of the engineers for them too. And our contact information is on the last page of this presentation also. Good. Well, let's get started. So the regions for Central Air Conditioning Energy Efficiency Standards 2023. Just keep in mind that the presentation and the major changes that are happening are primarily limited, and the presentation is limited to DX systems, with direct expansion system, whether they are split systems or whether they are package units, basically. So the 2023 changes are primarily divided into 3 categories over here. North, southeast, and southwest, basically. So minimum efficiency increases not only by product type, but by geographic region. Just wanted to point out is that this is probably one of the first time in which there is a distinction made between the north, southeast, and southwest. They are slightly different efficiency standards. And what DOE has tried to do is to come up with a more realistic efficiencies based on the region you are in. So the requirement for efficiency are slightly lower in the north, and they are higher in the southeast and southwest. Also want to let you all know that this is something that has been in the works since 2018. So a lot of manufacturers are aware of it. It had a major impact on the manufacturers, and so mostly it is related impact is on the manufacturers, but the owner needs to be kind of aware of it, and I'll explain all those in the next few slides. So the 2023 DX efficiency changes, this is just a brief overview of this. As of January 1, 2023, U.S. Department of Energy, which is also shortened DOE, no minimum efficiency standards will go into effect. New efficiency standards for residential and commercial HVAC equipment. So residential and commercial HVAC equipment. Ongoing initiative with the goal to reduce overall energy consumption in the U.S., package and split DX system, AC system, and heat pump units. Basically, there are changes in the efficiency standards and we'll have new efficiencies for those. On the natural gas furnaces and heating side, very minimum changes, primarily the natural gas heating efficiency for units that are greater than 225,000 BTUs. Their minimum efficiency, currently it is 80% efficient. In 2023, they will be required to be at least 81% efficient. So most manufacturers, as I mentioned, have or are busy with updating products that meet the new 2023 requirements. So, and with the pandemic and the supply chain issues, there are, most manufacturers are having issues with the product. So it kind of makes it even slightly more complicated for that purposes. So what I wanted to do was give you a little bit of background on the how all of this works. So the national model on energy codes is developed by two private organizations, which is ASHRAE and International Code Council. So ASHRAE develops the Model Commercial Energy Code, also known as 90.1, and the International Code Council develops International Energy Conservation Code, which contains chapters for both residential and commercial buildings. So something to just keep in mind that these are the two main organizations that handle codes, and the codes are, the cycle time for code is on every 3 years. So if you have a 2018 code, then the next code will be 2018 is one, and 3 years from that will be 2021. So the 2020, and the next code is expected, updates are expected to be in 2023 or 4, I believe. Yes, 34. Okay. So also something to keep in mind is that DO participates in both ASHRAE and ICC development process, but has no special status. But DOE develops and submits code changes proposal that strive to make cost-effective, energy-efficient upgrade to current code models. After a few new model code is published, DOE also must determine if the new version saves energy relative to the old one. So DOE has an important role to play in this thing, and I just wanted to give you all a little bit of background on which are the organizations that are in the forefront and which are the organizations that are in the background working on it. So another organization, and I want you all to be kind of familiar with, that deals with the DX system efficiency standards is AHRI, which stands for Air Conditioning, Heating, and Refrigeration Institute. They are the certification organization that provides accurate and unbiased technical performance standards for the HVAC industry, establishes rating criteria and procedures to evaluate and certify manufacturers' equipment efficiencies, and units that are 5.4 ton or smaller has a testing standard that goes through. It's called AHRI 21, 210, and 240. Larger units, which are bigger than 5.4 ton, go through a testing standard that's AHRI 34/360. Chillers have got their separate status over there, but we're not covering chillers and all that because they've not been any significant changes over there in the testing procedures. Mostly it is the DX system that's been impacted. So the 2023 efficiency, and primarily for smaller units, I would say less than 5 tons, typically less than 5-ton units. So typically we'll see them 2.5, 3-ton range, but anything less than 5 ton is the residential and light commercial units that have been very greatly impacted. And I'll explain all that in a short. Units to meet more stringent testing requirement for single-phase product manufactured on or before January 1st, 2023. So what has happened is that there were some standard criteria and factors that were inputted in how they used to do the testing. And what has happened is that some of those criteria has been updated to make it more realistic, basically. So the test condition, one of the primary one, there are a lot of them, but the primary one is that these smaller units, anything less than 5 tons, used to be tested with an external static pressure of 0.3 inches of water column, and that has changed now to 0.5 inches of water column, as I said, to more accurately reflect field conditions. What is external static pressure? It is all the pressure outside the unit or that the flow, the fan or the blower has to overcome to deliver air to space. That means whatever pressure that has to overcome in the supply and return duct, grills and diffusers basically is taken into account. It used to be zero point 0.3, which a lot of people thought was not realistic. And so now it has been changed to zero point 0.5 basically. So that's one important impact. So now all testing has to happen at 0.5 inches of water column. Now, a lot of school districts, small offices, and a lot of commercials, they do use 5 tons or less units. Some of them are single phase, but there are also a lot of locations or where they have three phase. The three phase units will also in this category will have changes on new standards, but they'll be a couple of years behind in 2025. So the main goal of this 2023 in the units less than 5 tons range is towards the single phase units. And one other thing that I'm going to be describing the what you see SEER, EER, HSPF. They have some new designations, changing them to SEER 2, EER 2, and HSPF 2. I'll be describing each one of them a little bit more detail. These are the efficiency rating systems that are existing, and where they have the two, that's the new ratings basically. So the minimum efficiency increases not only by the product but by geographic region. So they have a slightly less efficient units on the cooling side. They allow that in the north basically, and southeast and southwest they've got a slightly higher efficient units minimum standards basically. So it used to be one for the entire US. Now there's a little distinction over there, and mostly it is to reflect the actual conditions basically. Before we go too much into it, what I like to do is just give you a little bit of background on where you will find the energy efficiency minimum standards for the equipment. And I'm just doing a slight comparison between 2018 and 2021. So most of the jurisdictions have currently 2018 International Energy Conservation Code. Um, but a lot of jurisdictions have adopted IEC 2021. So I wanted to just give you a little bit of background on those and try to explain some differences over there. Fortunately, the sections that deal with the minimum efficiency standards or ratings have not changed. So whether you're looking at 2018 code or you're looking at 2021, the sections, which is C403, that describes or puts tables over there to define what the minimum standards, efficiency standards, they are the same. However, in 2021, there are some climate zone changes, and these are directly result of a global warming potential and so forth. And I will show you how does it impact Texas over there in the next few slides. And the minimum efficiency changes from 2018 are changing in 2021. It is important to keep in mind that when codes are developed a little earlier before they are officially put out on the streets, the 2021 code was anticipating, and they were aware of the changes that will happen in 2023. So as a result, when I show you a couple of tables, they've got a slight description of what is supposed to be if the unit is installed before a certain date, and what the efficiency needs to be if it is installed or manufactured of a certain date, basically. So I'll show you those in the specific tables over there. So the building mechanical systems is covered in section C. C stands for commercial code area 403. So if you want to go look at what your heating and cooling equipment efficiencies will be, you will have to go to C403.3. If you want to go look at your heating and cooling system controls requirements are in the code, you have to go to C403.4. And if you want to know what the ventilation and exhaust system code requirements are, you have to go to section C403.7. For other areas, service water heating, lighting controls, there are different sections over there, and I've just listed them just for information only. So I just want to make sure that everyone is kind of familiar with the International Energy Code and where to find the minimum efficiencies for equipment. So this is a climate zone map from 2018. Primarily, what it is the energy code kind of has divided the whole U.S. into three broader regions. One of them is called A for moist, B for dry, and C for marine conditions, basically. And they have a dividing line basically between these three zones, the big zones over there. And they have a lot of zones or subzones within those big boundaries that I'm alluding to. And there are specific requirements and changes that are in effect in 2021, but there are specific efficiency requirements and economizer requirements that are going to be described in these. If you're in zone 2 or you're in zone 3 or you're in zone 5 or 6, you've got slightly different requirements to meet when you are designing your system and you're implementing those systems. So primarily, I wanted to give you a quick, a broad overview of what the map looks like. So if you go to your energy conservation code, and these small little blocks are all counties. Okay, so they have a list. It's hard to tell which county you would be from this map, but they have a table in the energy conservation IECC code that has all the counties listed throughout the United States and what zone they are in. So the way you work on your minimum standards is you first go to this map, then you go to you figure out which county zone you are in, and then when you are looking at the efficiency requirements and standards and code requirements, you have just got to keep in mind what zone you actually belong in, basically. So, and those are all done by the county, okay? And there was a little distinction over here that anything below this line over there used to be called warm and humid below the white line over here, okay? So, and I'll explain that a little bit later too. This is the 2021 IEC climate zone. You will not be able to tell by just looking at it if there was any major changes, but there were a lot of climate zones have been moved around basically, and it's very hard to tell just by looking at it and looking at the color coding over here. So what I will do is that primarily the A, B, and the C, which is moist, dry, and marine, those stay the same, but within those boundaries, there are changes in the zones classification. So they've moved from one zone to another. And when you do that, it has some impact on your design and installation and construction standards, basically. So what I'll do is at the next slide is I'm going to go zoom in on Texas, which where we are. And I will just go a little bit more detail on what the climate zones are. So basically, in Texas, they have got 3A, 2A, 1A, 2B, 3B, and 4B. These are the climate zones that exist. And then there's a listing of counties, basically, that will tell you exactly. You can't tell from the map, but primarily the color code is if you're this red area over there, then you are in hot and humid, which is 2A. If you are in this purple, your county's colored purple, then you are in very hot and humid, and so on and so forth. So just keep that in mind. There's a table over there, and there are changes. So, for example, the DFW area counties, which is Dallas, Tarrant, Johnson, Ellis, and Navarro, have changed from warm and humid, which used to be 3A, to hot and humid now, 2A. So that there's been changes over there. And further down in the south, like from Brownsville, South Padre Island area counties, which is Hidalgo, Willisi and Cameron, has changed from hot and humid, which used to be 2A in 2018, to very hot and humid, which is 1A. These are some pretty good significant changes, specifically if you are in these counties. The other county requirements are pretty much whatever they were in 2018. So you can see that there is at least a shift basically, and that's the representative of things are getting hotter, I guess. Well, I like to take a few moments and just go over some of the basic definitions and where do they apply. And the next few slides are going to those aspects of it. So bear with me. Primarily, what I'll be going over is SEER, Seasonal Energy Efficiency Ratio, and then there will be a new standard 2023, SEER 2, which I'll describe. EER is Energy Efficiency Ratio. EER2 will be something coming up for products that will have to be rated basically in EER2 and 2023. HSPF is Heating Season Performance Factor. That mostly applies to heat pump units, and there are efficiency changes over there. Also, they have now introduced IEER, which is Integrated Energy Efficiency Ratio, and those will be applied to DX systems also. And then the last few of them, I'm just going to very briefly go over them, and I have a slide on them. The COP, kW per ton, and IPLV are, which is integrated power load value, mostly applicable to chillers basically. And chillers efficiency standards and so forth are what they're established. But the major changes and what we are covering is the DX system. So I just want to let you all know that we'll be covering each of them very briefly because it is important to kind of have an idea of what this is and how do you compare it to what was in the past, and just have a basic understanding of these terms that you will see very often. So SEER is seasonal energy efficiency ratio, is the ratio of HVAC system cooling output to energy consumed in watt hour during the cooling season. So during the cooling season, so SEER is cooling output divided by energy consumed over the season, and typically it's in BTUs per watt hour. So the higher the SEER number, the more efficient the unit. So 18 SEER HVAC system is more efficient than 16 SEER system. SEER 2 will have a similar definition, but it will be tested under stringent test conditions. So typically SEER 2 will be a lower number than SEER 1, and it gets a little confusing, but the unit will be more efficient, okay? So just something to keep in mind. So SEER is calculated with the same indoor temperature, but over a range of outdoor temperatures with a certain specified percentage of time in each temperature bins. That's the general definition of SEER, and mostly it is done over a cooling season, EER is the energy efficiency rate. Let me go back one more thing over here. So just keep in mind that if you've got units that are typically 5 tons or lower, you will see a SEER rating on them. Okay, the SEER rating typically applies to a smaller unit, typically 510 or 5.5 ton or smaller units, anything that's less than that. EER, energy efficiency ratio. That's the ratio of HVAC system cooling output to input electrical energy consumed, watt hours again, at a given operating conditions. So SEER was was primarily during the cooling season, and this is throughout the year at a given operating conditions. And I'll describe that in a little while. If you look at it, the units are identical. So it's cooling output divided by total energy consumed, which is BTU per watt. So typically, the higher the EER, the more efficient the unit is. And then if, for example, if you have an EER of 11.5, it is more efficient than EER of 10.5. That's understood. EER2 is very similar but stringent test conditions. So that if the formula, how it's calculated, the efficiency doesn't change. However, they put some more stringent conditions that they have to overcome. As a result, the EER2 value will be lower number compared to EER, but the unit will be more efficient, just like SEER, basically. So something to just keep in mind. And typically, you used to see, or you will be seeing, EER for units that are over 5 tons. So their efficiencies are typically defined in EER, and if it is less than 5 ton, their efficiency is typically defined. The cooling efficiency I'm talking about is typically defined in SEER. So that's one distinction we want to make sure. So the energy efficiency ratio, or the EER, is the value showing the efficiency of a system at peak load. That is important. So they look at the peak load and what is the efficiency of that system. EER is generally calculated using a 95-degree ambient conditions and an inside or a mixed air temperature of close to 80 with a relative humidity in the space of 50. So they define these conditions basically over there, in which these things are tested. So that's the main difference between SEER and EER. So a lot of time you may be asked to just kind of directly relate SEER to EER. There is no direct correlation, but typically what you will see that the SEER is a higher value than EER for the same HVAC system. Okay, basically, and just a general rule of thumb is that EER will be equal to 0.875 times SEER. So you'll see slightly less than SEER, and that's how you can generally come up with what if you're just comparing EERs for different systems. It can get complicated, and there are different formulas if you want to do it more accurately, but if you're just trying to have a rule of thumb, you'll be pretty close by using that formula. So you can see on the right side over there is that if a unit has got a SEER of 14, it will be equivalent to a unit with EER of 12.3. So similarly, if you got a SEER of 15, the EER will be equal to 13.1, basically. Again, this is something if you just want to compare EER to SEER, but the smaller units, as I mentioned, will have a rating in SEER, and 5 tons or larger are going to be rated in EER. A new definition, well, not very new. It's been around, it's been around for a little while, but a new uh, term that you will see that is going to be most of these units are going to be rated on is the IEER, Integrated Energy Efficiency Ratio, and you will start seeing them in the code books and in the publication and so forth. It expresses cooling part load on the basis of weighted operation at various load capacities. So literally what they have done is that they used to do that with the chillers when they came up with integrated part load efficiencies. The same thing has been done with the DX systems now, and they want to have a more realistic efficiency at different operating conditions. So that's primarily what it is, and it will be used going forward in the tables and publications for units that are bigger than 65,000 BTUH, which is roughly 5.4 tons. So all those larger units that are bigger than 5 or 5.5 ton, you will start seeing the efficiency ratings in IEER. What is IEER? The concept is pretty much the same as SEER, but it's got more weighted average. So IEER will be something that will be calculated at different load conditions, and that's the formula for it. Basically, if you're interested in that, and what you will see is that they are calculating the EER of the unit at peak, at 95, at 81, at 68, and 65, and they've given some weighted averages to those to come up with the IER number. So that's something to just keep in mind. Before, the EER used to be just one number that was at a particular condition, which was 95-degree ambient. The IER is more the weighted average of it at different conditions over there. Now, if you're dealing with the heat pumps, there'll be some changes over there also. So HSPF is heating seasonal performance factor. HSPF is specifically used to measure the efficiency of air source heat pumps. Very important, air source heat pumps. HSPF is defined as the ratio of heat output in BTUs over the heating season to electricity use in watt hour. And you will see the formula is pretty much the same. The units are almost the same, not almost, but pretty much the same. But the only difference is this is over a period of heating. So this is the efficiency of that heat pump over the heating season. The cooling season will stay the same. The heat pumps work on in cooling and heating season. It just reverses the cycle. So the cooling efficiencies will be defined by the SEER or EER or IER, but the HSPF will be defined under this condition over here. I'm going to very quickly go through these just for information only. So the other, uh, um, efficiency ratings or that you will see very common is the COP, which is the coefficient of performance, basically, and it's the ratio of cooling or heating generated to the power supply to the compressor. So it's pretty much how much you are cooling, you're generating, and how much power you're supplying, the ratio to that. And it's the COP. Lot of can be calculated by dividing the EER divided by 3.41, and the COP is typically a unitless rating, basically. So you will see a COP of 3, 4, and 5. Again, the higher the number, the more efficient they are. But that's something that you might see from time to time. The kW per ton, if it is kilowatts per ton, is the ratio of energy consumed in kilowatt to the rate of heat removal in tons at the rated conditions. So it is, you will see a lot of the chillers, people like to define them in kW per ton. You can also do that with the DX systems also. And if you already know the EER, in order to have the kW per ton, the formula is you divide 12 divided by EER, and that will give you the kW per ton, basically. So you can, if you don't have or you're just interested what that number would be, what the kW per ton will be, you can do that. The IPLV is the integrated part load value, is a weighted average efficiency at part load conditions. And these are mostly for chillers over here. So, because what they realize is the chiller usually is working at peak load, normally at 1% of time, and mostly it is in different part load conditions. At 75% of the load is usually, loading is, it's 42% of time, it's in the 75% range, and so on and so forth. So again, the IPLV is the weighted average, and it's a good representation of how efficient that unit is going to be over the period of operating time for that thing. So mostly a lot of these you will see in the if you're going into the chillers and trying to look at the efficiencies for the chillers. As I mentioned earlier, that the 2021 Energy Code, when they were writing that, they were anticipating these changes. So some of the new ratings and so forth are kind of listed in the table. So I've just given you a couple of examples over there. These are excerpts from table C403.3.2. And this is table 1 over there, which is mostly for split DX systems and split systems over there. So it says that if you have an air conditioner that is less than 65,000 BTUH capacity, which is roughly comes out to 5.4 ton, no matter what type it is, a single phase, mostly this is single phase units. These are the categories. So if you were manufacturing them or you were, before 1/1/2023, which is next year, the minimum efficiency SEER was 13. When the new ratings are going to be developed, and you need to meet 13.4 SEER2 requirements. Okay, basically, this is where they have made the testing a little bit more stringent. So again, as I mentioned, AHRI is the testing procedure, and these have to be tested under these procedures, and these ratings have to meet these current procedures over there. Similarly, if you have something less than 2.5 tons, they were anticipating the changes that would be impacted on the smaller units, and then you see different dates and minimum efficiency standards for those dates over there. When you go to larger units, basically anything over 5.5 or 5.4 tons up to 11.25 tons. So you will see whether you've got electric resistance or all others. They have EER, and then they have IEER if the unit is going to be installed after January 1st, 2023, basically. So again, you see there used to be the EER rating was there, but they have developed, they have raised that IEER rating, and that's the minimum rating over there that you need to have. You can similarly go down the line on that 2021 code, and you will see the ratings, the EER and the IEER ratings. So remember, I was telling you that the smaller units, 5.5 tons or smaller, are typically rated in SEER. Then the larger units, bigger than 5.5 tons, are rated in EER, or they were in EER, and they still will be in EER, but also they have to meet the IEER requirement after January 1st, 2023, and some of those standards are kind of identified over here. Similarly, these are again split systems, 20 tons and up to 63.3 tons. And then, of course, there are occasions where you can have something way bigger than 63 tons also. And they have defined the EERs and IEERs and the applicable dates for those systems over there. So something to just keep in mind. And if you're interested in looking into what your efficiencies need to be after January 1st, 2023, these are the new efficiencies that you need to meet. Well, these are some more tables for unitary heat pumps, basically. So heat pumps have got a different table, and they have the same kind of a classification and differentiations, basically. And you'll see two different dates over there, and you will see a CO2 ratings for smaller units, and if they're bigger than that, you'll see EER ratings. So same concept. The table for the heat pump units is C403.3.2. and it's table 2 over there. And that continues just like the regular HVAC systems that are not heat pumps. They have similar classifications and different tonnage capacities and different EER and IER rating as we discussed for the split systems over there. And that continues basically. So you can have larger, very large size heat pump units also. They are available in all sizes. So what we've tried to do is we just looked at different sources and tried to summarize some of these findings over there so that's slightly easier to navigate. A lot of manufacturers have done something similar to that. They have a slightly different approaches, but you'll find that some of this information published document. So basically, if it's a package unit heat pump, it is less than 65,000 BTUs capacity. No matter what type it is, before 2023, it used to have a minimum, this is 2018, basically, a SEER of 14, but after 2023, it needs to have a standard rating of 13.4 SEER 2. Now, as I mentioned earlier, the SEER 2 will be a lower number than SEER, but in reality is more efficient than SEER because of the testing conditions that they put over there. So I just want to make sure that there's no confusion over there. And when you see a lower number, the SEER 2 is the trick because they've got more stringent conditions over there. So roughly, the SEER 2 is almost 1 point more efficient than your regular SEER. Okay, if you just want to round it off. So SEER 2 is roughly 1 point more efficient, typically 1 point more efficient than your standard old SEER, basically. So then you can see this is the same table. You will see IERs, what was there before 2023 and what are they required to be after 2023. And you'll see a significant changes and upgrades over there, more way more efficient systems over there. In fact, the DOE estimates the new standard will result in cumulative cost reduction in CO2 emissions through 2030 amounting to close to 77 million metric ton, which is equivalent to emission resulting from annual electricity use of more than 10.6 million homes. So these efficiency standards, when applied and throughout the U.S., is going to result in significant CO2 emission reductions. So overall, good for environment and more efficient systems. What I want to do is take a few moments and just go over some very basic things that you will be expecting. There are efficiency changes, and then there are changes in the refrigerant that are going to be used basically down the line. So I wanted to define two things that how the that relates to the refrigerants. So one is the GWP, which is a global warming potential, is the ratio of ability of a substance to trap heat in atmosphere to that of a carbon dioxide used for upcoming refrigerant systems. So the GWP is the number that you need to be looking at, and those are going to be mandated for the refrigerants that are coming down the line. In the past, it used to be ODP, which is ozone depletion potential, and the ratio of the ability of a substance to degrade ozone to that of CFC11. Now, if you all remember, the CFC was a very old refrigerant system, so they have a baseline, and they're just looking at how much will it degrade compared to that baseline, and mostly used on the older system. So basically, the intention is to put the greenhouse gas emission onto a common scale. As a result, more and more people, and the standards are going to be referring to GWP as opposed to ODP, which was primarily the driving force in the past, but going forward is going to be global warming potential. So just wanted to make sure that these two terminologies are you're kind of familiar with that, and you'll be seeing more of it. So 2025 refrigerant transition date. So there has been a refrigerant transition date that's been established basically, which is 2025. Previously, as I mentioned, refrigerants were transitions were addressing the ODP, which is the ozone depletion potential. The new refrigerant transition will be addressing the GWP, which is the global warming potential, and the new limit is it needs to be 750 GWP or lower. So today's dominant refrigerant, for example, is the 410A, mostly in the small DX system. It has a GWP of 2088, and it has an ODP of 0. So that's mostly what you have right now. And I just wanted to show you what that looks like. So the other question is, what are the two, there are two leading replacement candidates for 410A, which are, R32 and R454B. Manufacturers are, some of them are using R32 and some of them are going to be standardizing for a variety of reasons, R45B, but these are the new refrigerants that you will be seeing down the line, and they'll be mandated. The performance are very similar to 410A, and for split systems, both the indoor and outdoor unit must be replaced in order to make these new refrigerant systems work. Use of existing refrigerant, question comes up, well, we have got a split system, we got existing refrigerant lines. So I believe that you would be able to use, and you'll have to check on individual case basis, but you could use the individual lines, but I will say they'll be anticipate a similar procedures in the previous transition when we went from R22 to R410. You had to vacuum and flush the line, clean the old refrigerant lines to make sure that they were suitable for 410 applications. I expect there'll be a similar requirement over here. Ideally, if you can change the refrigerant line, but we know that from construction point of view, a lot of them will have a significant cost. So if we can reuse the existing lines, but there might have to be few steps taken, just like in the past, to make sure that you don't have issues with it. Again, the emphasis is that it has to be checked on individual basis, but you just need to be familiar with and keep that in mind. Again, the 410 and all will go out of production, but they'll still be around, just like when you were dealing with R22 to 410. So I guess in the next few years, I'll be seeing people storing 410 for reuse. And so just something to keep in mind that there's something similar coming down the pipeline, and you all just need to be aware of it. So manufacturers, I don't think all of them are ready to put, ready right now, but by 2025, they will be, and the newer system will have newer refrigerants in them. So this is just another table that I wanted to put out there that shows the refrigerant transition dates, just some historical background, and what were the GWP and ODPs in the past. So for those of us who remember R4 R12, which is a CFC, basically, there was no transition date initially. That was the refrigerant that they had. It has a high GWP and a very high ODP. Then a transitions was made from R12 to R22. So most of the chillers and older systems, people had to go and upgrade them to R22. That transition for hydrochlorofluorocarbons, which is HCFC, happened in 1996. The GWP was high, which was 1800, but the ODP was 0.055, which is a lower number basically compared to R12. So then a transition in 2010 was made to R410, mostly for split system and DH systems. Similar transitions, 134 and so forth for other systems over there. But the R410, which you commonly see in the smaller DX systems, had a high GWB, which was 2088, but the ozone depletion potential was zero. Now remember, when this transition was done, people were more concerned about the ozone layer, which is still they're concerned about, and they were just focused on one item that they're looking at that. So they wanted lower ODPs, but nobody cared about the GWB, or it wasn't defined at that point in time. Now, what has happened is that since then, more research has been done, and it has been determined that the GWP, which is a composite, it takes a lot of factors, it takes into ozone and other factors into account. So most people, there's still debates on it, but the GWP is the new going standards. You won't see a change in the ODP. Basically, people have attained zero ODP before, but now you got to also attain a low GWB on the refrigerant. So the R32, I think some of the manufacturers like Daikin and a few others potentially are zoomed in on R32, and they'll be potentially ready by 2025. It will have a GWB of 675 and ODP of 0. And a lot of other manufacturers are looking at R454B, which is HFC. Again, by 2025, it has a GWB of 466 and ODP of 0. The key thing to keep in mind is this new standard in 2025 is that the GWB, which is this factor, this needs to be lower than 750. So going forward, you all need to be aware of that, and then start planning, from maintenance and construction standards and so forth, at least need to be kind of aware of these things over there. So this was just a very simplistically putting over there and just comparing. So you'll see a trend over a period of time where you had high ODP and GWP potentials, and then all of a sudden the ODP went down to 0, but the number was still high, and now that has been moved down to almost less than 750. So the main emphasis going forward will be the GWP number to look at the refrigerant over there, basically, right? So the transition, I think, will be similar to what you guys were handling as a part of the as a part of the as a part of the transition in the past. Similar procedures will be in place, basically. Okay, so I think we have one question over here. It's a question: would the lubricating oil be the same for the replacement of 410? That's a good question. I don't have too much specific on that, but um, uh, they're still going through that evaluation. There are some slight differences over there. So that's why it is still recommended to vacuum and take the oil out of the system, basically. And there's a recommendation for changing the indoor and the outdoor units. So I suspect that will have an impact, and probably there are some differences over there, is what I suspect. Um, So, sorry, I was just having some hard time going to the last slide over there. We have very little time left, couple of minutes left. There was one question about that, and I will look into that more and then answer everybody with more specifics. But the question was, will the lubricating oil be the same for replacement of 410? And I suspect there is some differences over there. That's why they're recommending change out of indoor and outdoor unit, and ideally new refrigerant line, or at least vacuum all the oil out from the whole system, basically. But I'll get that answered also. So again, if there were, this is my contact information. This is a new topic over here, something that I just want everyone to be aware of. There are these changes that are on the horizon, basically. It has a major impact on the suppliers, and they're still dealing with it. But there could be, impact on the owner side of it also, and want to make sure that you are just somewhat familiar what's on the horizon over there. There's also, if you have if you want to know more about the local government program, you can contact LaShawn over there. If you have questions on this presentation, you can contact me, and I can also answer you any question you all may have on the local government program. Well, I hope this was helpful. I think I wanted to give you just a brief outlook and just have with you some basic information over there. I hope this helped. And if there are no more questions, I like to thank everyone for taking part in this thing, and hopefully you all could join the PV system that we'll be discussing in a little while. And I will go from here. And thank you for the compliments, USD. But I'll again, you feel free to contact me anytime you want. With this, I like to wrap up over here, and once again thank everyone for their participation in this webinar. Thank you.